It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources, but still. And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. Natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule, but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid, but it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these mega quakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater arms in, they spin faster. Arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin, and if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting.
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it. All these findings are rather disturbing. But understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, At the moment, the moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's gonna be fine. At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle, and not just local eruptions.
It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has three main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the two blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists look closely at their chemical makeup, they realize the age of crystals matched the rocks found in Greenland, not Scandinavia. They use special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other.
Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a Centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. they erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsunamis Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transitioned from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase, or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out.
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a super eruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news. because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascade subduction zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gurwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.